Hey everyone, welcome back to my YouTube channel SummarizedAI. When we ask AI a question for what it don't have a context or knowledge, it tries to answer just from what it remembers or pre-trained on. Like a student recalling facts from memory, this can work for common questions, but what if the information is new, very specific, or detailed? The AI might give a wrong or incomplete answer. This is where RAG comes in picture, which is called as Retrieval-Augmented Generation. RAG first searches through a large collection of documents, articles, or data to find the most relevant pieces of information and then uses that information to generate an answer. In our previous video, we discussed semantic search, vector embeddings, and FAISS as vector database in detail, exploring how they help in efficiently storing and retrieving information based on meaning rather than just keywords. In this video, we will dive deep into RAG, explaining how it combines the power of information retrieval with generative AI to provide more accurate and context-aware response. Context-aware response means the AI doesn't just give a standard or random answer. It makes sure the response is accurate and based on the most useful information it can find. Imagine having a really smart assistant who reads through all the relevant documents first and then give you an answer so you know it's reliable and on point. Great. Let's first understand RAG on very high level and how it works. Suppose we have a collection of documents. First, we break these documents into smaller chunks to make the easier to process. Then for each chunk, we create a vector embedding, which is numerical representation that captures the meaning of the text. These embeddings are then stored into a vector database, which is optimized for fast similarity searches. Now, when a user submits a query or prompt, then system converts the query into vector embedding as well. This query vector is then compared against the vector stored in the database to find the most similar chunks. The database returns the top K related results, which is in the pieces of content most relevant to the query. Finally, these retrieved chunks are passed to one of the large language model, which processes and synthesizes the information to generate a coherent, context-aware answer for the user. In this way, the system combines semantic search with the generative power of LLMs, ensuring the answer are both relevant and accurate. Now, before we deep diving into RAG, we should understand why we need RAG and its importance. Very first point is for accuracy. Answers are based on real, up-to-date sources, not just AI's memory. Second is context aware, where AI can provide answers tailored to your specific question. The third one is scalability, where it can handle large amount of information than a human or a standard AI might struggle with. And the fourth, last point is trustworthiness. Since the response comes from verified sources, you can rely it on very easily. Great. Now, as a RAG developer, let's understand the overall process step by step in detail. So, step one is to load the documents. Gather all the document or data we want our AI to learn from. It can be PDFs, articles, or any text files. Okay. Now, the second step is to load required Python libraries. Import the necessary libraries that will help us process the data, such as tools for embeddings, text chunking, and vector databases. Now, the step three is to chunk the documents. As we know, large documents are often broken into smaller pieces called chunks. This helps the AI process and understand the text more effectively. The fourth step is to create vector embedding. Use a model like one from sentence transformers or OpenAI embeddings to convert each text chunks into number, which also called as vector embeddings. These embeddings capture the meaning of the text. Okay. Now the step five is to store embeddings in a vector database. These numerical representations are stored in a vector database such as FAISS, Pinecone, or Chroma, which allows for fast and efficient similarity searches. Now, perform a search. Okay, when a user asks a question or a query or a prompt, gets gets converted into vector embedding as well. So if someone is asking a query, that particular query first will get converted into the vector embedding, which is numbers, and then it's a right for similarity search to come in picture. Now the similarity search will be coming in picture. Query vector with the stored vectors in the database to find the most similar or relevant pieces of information, usually return the top key results. Finally, large language models comes in picture to take these top results, understand the context, and generate the final well-structured answer for the user. So this was all about the overall process of RAG, how it works from having the content to embedding and get the relevant result. Now let's go back to our Visual Studio and we will implement drag. I will create a file practice.py. Okay. And before we start our implementation, we require these Python libraries in our local. Okay. So to have these Python libraries in our local, we have to run these three commands individually: pip install FAISS, pip install SentenceTransformers, pip install OpenAI. Once these Python libraries are installed, we can go ahead and do our implementation. At current point of time, I'm already having these libraries in my local, so I won't be installing it and starting the implementation right away. So let me go ahead and import FAISS, okay, and then let me import sentence transformers, okay, and then let me import OpenAI, okay. Imports are done. Now we require to have a API key from OpenAI to access the LLMs. So I will be getting the API key. I will be placing this API key here. We can have the API keys directly from the operating system. What we can do is we can keep this API key as a system variable, okay? Or we can save this as part of the config.yaml here only and just import it here to use. But for this particular block and for the easiness for everyone, I'm keeping it hard coded in the code file itself. Now I'm already having my knowledge base ready. I have already created that knowledge base, which we are going to embed in our vector database. And this is all about like the fruits and vegetables, okay, the grocery items. So this is there. Now what we're gonna do is we gonna get the model. So sentence transformer model we're gonna get, okay, and we gonna use all hyphen mini lm hyphen l6 hyphen v2 model we are going to use. Now, once we have this particular model, we can generate embeddings. So embeddings equal to model dot encode, and inside it we are going to pass grocery items and have it as type float 32 float 32. Okay, so now we have the embedding ready with us. Now we are going to create FAISS index. Okay, so for that we first require a dimension, and that dimension we can get from embeddings dot shape 1. Okay, once you have the dimension we can get the index FAISS dot index flat L2, and then pass this dimension here, and then we are gonna get the index dot add, and then we are going to get the embeddings. So this particular index got created. Now we are going to define the query which we're gonna ask from vector database. So I want to buy some healthy food rich in vitamins and minerals. Okay, so my query is ready. Now we will create a query vector. So as earlier discussed, we're gonna create the vector for vector embedding for this content also, knowledge base, and we're gonna create a vector embedding for query also so that it can compare those numbers and get the result. So query vector equal to model dot encode, in the bracket we have query dot as type float 32. Okay, now we got this. Now once we have query vector, we require to have number of relevant results. So we are going to have 3 relevant result, and I'm going to have the distance and indices of those results. I will explain you what are these distance and the indices. So don't worry about that. So index dot search, and then query vector comma number of relevant result. Now, or the top result. Now this is there. Now we are going to create retrieved documents, grocery items, I or I in indices of 0, and close this. Mm, indices items for I in indices. Okay, we have the retrieve docs here. Now we are going to get the context. So context equal to backslash and dot join, and then inside it we are going to say retrieve docs, and then we are going to create our prompt. So for prompt, we require the context and the query. Query we have already defined here, and the context we have here. Okay, so let's create our query. So I have this, and then we're gonna say you are a helpful assistant. Okay, let me close it or it will show an error. Now we are going to provide context. Okay, we are going to say context. Okay, now below we are going to say user query is nothing but our prompt. Okay, sorry, query, it is our query, what we have defined here. Okay, now when we have both these things, now we are going to say using the context above, suggest items best as the user's request and explain why. Okay, so we have created our prompt here using query and the context. Now we are going to call ChatGPT GPT-4 Omni model. So response equal to client dot chat dot completions dot create, which is the most common code we have from ChatGPT. So give the model name here GPT hyphen 4 O hyphen mini comma, and then pass your messages equals to, then we are gonna say this, and then we're gonna say message is equal to this, and then inside it we have object which says role user, and then comma, we need to have content also, and content is nothing but our prompt. This is like most common what we use for every chat completion in chat GPT. We have this, and then we have this. Let's format it. Okay, now we got this command. Okay, so here the chat GPT will help us to explain and summarize results in natural language or in the format whichever we need. Like if we require in JSON or any other format, it will give us based on our query. Now we are going to get the retrieve documents. Okay, so for getting a retrieve documents, you can say for doc in retrieve docs. Okay, and then you can say print doc. Okay, this is there. Now at last we are going to print the response from the chat GPT. So print, and then we can say response dot choices, then 0 dot message dot content. Okay, this is the response we have from ChatGPT. This is like very common when we make a ChatGPT call. Okay, now I'm going to print one more thing here where we were getting distance and indices. I will explain what it is. Now let's run this code and see. So this code will get run. While running, it will go through that knowledge base. It will create the vector embeddings, and after creating vector embedding, it will keep it into the vector database, which is FAISS. And then we will have this query. Query will also get converted into vector embedding, and this vector embedding get compare in the database, and then it will return us the top 3 result. So if you see here, it returned us 3 results where we saw the distance and indices here, distance and indices. Okay, so this distance is nothing but the distance of that particular test result from the neutral point. So whichever distance is low, that will be the most relevant or the accurate result. Okay, and as the distance gets increased, the result will not be that relevant. Cool. Now once we get this particular result, we gonna pass this particular result or the context, okay, to prompt, and prompt will get called by the ChatGPT model. So what it will do, it will summarize our results and provide us the output the way we asked. So we said like using the context of a suggest which grocery item best match and why. So it will tell us the explanation also. So it is saying French Spanish leaves, Spanish is paired with this, and this, and looking is increase their iron. So it is telling us the reason also why this particular vegetable is good, okay, and providing the explanation also. So this is like end-to-end implementation of RAG. Okay. Now, um, point to be noted here, very important point, having FAISS plus sentence transformer plus ChatGPT. This is also called as RAG chain because this chain of modules makes the entire process of RAG. That's where we call it as RAG chain. And that's all we have for today. Thank you so much for watching this video. If you found this video helpful and want to see more video on AI, don't forget to like and click on notification icon to stay updated and subscribe to the channel. See you in the next video. Thank you.